Welcome back to this video tutorial. We can discuss about the storage classes in C language. The storage classes are used to describe the features of variable or function in C programming. Okay, used to describe the features of variable or function. And the features like scope, visibility and lifetime of variable. These features help us to trace out the existence of particular variable during program execution. Right? We have basically four type of storage classes in C like auto, extern, static and register. Okay, and for auto type variable, if it is declared and by default it is initialized with a garbage value. And for register type variable also, if it is declared, then by default it is initialized with garbage value. Garbage value means whatever value is present there in that particular location which is directly available in that particular variable declared. Okay, and for this external and static type variables, if it is declared and kept as uninitialized, then by default it is initialized with value 0 instead of our garbage value. Okay, so for external and static, if the variables are declared and kept as uninitialized, then by default it is initialized with value 0. And about the scope of this storage classes, and for auto type variables, its scope exists inside the block or inside a function body in which that particular declaration is present. Once more, auto type variable, its scope exists inside a block or inside a function body in which that particular variable declaration is present. And for extern type variables, its scope exists everywhere inside the program. That is why here it the representation global. Extern type variable, its scope exists everywhere everywhere in the program. And for static and register type variable also, the scope exists inside the block or inside the function body in which that particular variable declaration is present. And about the lifetime of this type of variables. For an auto type variables, the lifetime exists inside the block or inside a function body in which the particular variable declaration is present. And for external and static, the lifetime of that particular variable exists throughout the program. That means at the end of the program, its life exists. But here in case of auto type variable, the life end at the end of the block or at the end of the function body. But in case of external static, it keep its life till the end of the program execution. Okay, and for register also, if the block in which that particular register variable declaration is present, if the block terminate the execution, then the register type variable life also entered there. And is similarly for our auto type variable, its life also entered at the point of termination of a particular block or function body execution. Okay, but it's not the case of external and static type variable. Its life or its value retained until the end of the program execution. Okay, and now we can consider each of the classes in detail. First, about the auto. This auto type storage class are also known as local variables. Okay, this is the default storage class for all the variables declared inside a function or a block. Hence, the keyword auto is rarely used while writing programs in C language. So, consider one example. Here we have the main function in which we have an integer type variable n1 and its class is auto here. This auto is actually a default type. So, int n1 is directly indicate that this int n1 inside this main function is an auto type variable. Its life exists inside this function body. Here also inside this function, here we have integer variable n2. This is also an auto type variable. So this particular syntax auto int n1 is valid, and this one is also valid. Both in syntax indicate this n1 is an auto type integer variable. So syntax are equal, and the life of this auto type variable exists inside the function body. That means for this particular variable n1, its life exists inside this main function body, and for n2, its life exists inside this function body. Okay. And next about the registers type storage class, and is used to define local variables that should be stored in a register instead of RAM. That is, while declaring an auto type variables, its corresponding memory allocation takes place in our primary memory, that is inside our RAM memory. Okay, but in case of declaring a register type variable, associated or the corresponding allocation of storage space takes place inside our register set. This register set are actually indicate small amount of storage space directly available with the processors. Okay, so the limitation is, if the variable has a maximum size equal to the register size, then only we can declare register type variable. If we want to allot more amount of storage space, then we can't declare variable as register. If the variable has to store maximum size equal to the register size of our processor, that is usually a single word of processor, single memory word size equivalent. Okay, if we want to allocate a minimum amount of space for a particular variable, then only we can declare such variable as register. And what is the benefit of declaring a variable as register? Because while allotting space inside the register set of our processor, then the processor can quickly access such amount of values. That means registers are always associated with near to our processors. Processor can directly or fastly, quickly access data from our registers. So if we want to access, or if we want to provide some information quickly to our processor, then we can allot space in our register set. Instead of allotting space in prime memory, we can allot space in register set. But the limitation is, we can allot only a minimum amount of size equal to one word length for a particular register type variable. Okay, if we want to allot more amount of space for storing a particular value or for allotting for a particular variable, then we must allot that space in our primary memory. If the allocation is in primary memory, then that particular allocation never become a register type memory allocation. Okay, if the storage space is allotted in our register set associated with the processor, then only that particular variable become register type variable. If the variable is set as register type, then the processor can quickly access value from that particular storage space. Okay, that is the advantage of declaring a variable as register type. The syntax is like this: register int count, keyword register, then int count. From this the compiler identifies that here we need to allot space for a variable count in our register set, so that the processor can fastly access that particular value that is assigned to this particular variable in our program. Okay, next is about the static storage class. The static storage class instructs the compiler to keep a local variable in existence during the lifetime of the program instead of creating and destroying it each time it comes into and goes out of scope. That means this static type storage class give a lifetime to a particular local or auto type variable throughout the program. Okay, this static storage class is used to provide a lifetime to a particular local variable throughout our program execution. Okay, for making a local variable static allows them to retain their values between function calls. Okay, in order to understand this concept properly, now we can consider one program example. Okay, consider this one program. Okay, consider this one and consider here we have a function func. Okay, and inside the main function, here this count value is set as 3. Okay, and inside this while loop, if count greater than 0, it repeatedly call the function func. Okay, and each and every iteration, the value of the count decremented by 1. While calling this func function each and every time, what happened? Transfer control from this point to the body of this func function, and here the value of I is initialized as 5 first. Then it increment the value of I by 1 and display the value of I. Okay, what is the expected outcome of this particular program? So, first count value equal to 3. 3 greater than 0 is true case. So, execute the while loop body. So, for execution, here first statement is the function calling of this func function. So, transfer control from this point to this. Then here first statement is I equal to 5 and initialization. Then increment I by 1, I become 6. Then it display the value of I. I is 6 is displayed first. After executing this, control return back to this. Then execute the next instruction here, that is count minus minus. Now count become 2. Again go for this condition checking 2 greater than 0. So again condition true. So execute this func function for the next time, and while calling this func function, transfer control to this point, and here again this initialization. That means I become again assigned with the value 5. I increment to become 6. Then I display the value I is 6 again. After that, transfer control back to this location from where it is called, that is here, and execute the next instruction, that is count minus minus. Count become 1 now, 1 again greater than 0, and repeat the same. Again transfer here, I become 5, I plus plus means I become 6, and print the value 6 again. Okay, now we can check the output. So here it display I value I is 6 3 times, and for the fourth time count equal to count becomes 0, so the condition violated and program execution terminated. Okay, now we can consider one change over here in this program. Now consider this I as static. That means this integer variable I becomes static now. What is the meaning of the static? Now its value retain this program execution. That's the meaning. For the first time, while count equal to 3, this condition is satisfied, and while calling this, transfer here, and the first statement is initialize I with value 5. Then it increment by 1, I become 6, and display the value of this I as 6. After that, again go here and count become 2. 2 greater than 0 is true. So again call the function func. Right? So while calling this, transfer control here. Now it skip this initialization step, because for a static variable, it retain its value, previous value. Okay, so the previous I value is 6. So based on the value 6, it again perform I plus plus. So the I value becomes 7 now. So it display the value 7. Okay, so after that again go back and count become 1 greater than 0. So again call the function and transfer here and skip this initialization because this is a static type variable. It can retain the previous value. So previous value is 7. That 7 get incremented by 1, now become 8 and 8 is displayed. That is the significance of static type variable. The static type variable can retain the previous value in different function call. Okay, so throughout the program it can retain its value, and basically it can retain or keep the previous value, keep the previous updated value in different function calls. Okay, now we can execute this and check out the difference in output. So in first case it initialized value 5. The first time it performed this initialization, and I plus plus means I becomes 6 and this I value is 6 is displayed here. In the second iteration or second function call, based on the second function call, it skipped this initialization and retain the previous updated value, that is 6. So based on the previous value it performed the updation. Now the I value become 7. So that 7 is displayed here. And again go back to this while, and while calling the function again it comes here and avoid this initialization and increment the I value, and I value become 8. Based on the previous updated value it perform the updation again and display the new value. Okay, so this is the case of static type variable. Static type variable can retain the value, retain its previous value in different function calls. Okay, so this is the significance of using static type variable. It can continue its life throughout the program execution, and it can retain the previous value in different function calls. If it is not static, we need to perform this initialization again and again while performing the function call again and again. Okay, so this is the difference of declaring a variable as static. Okay, so now we can consider the last type of storage class, that is about the extern storage class. This is used to give a reference of a global variable that is visible to all the program files. The extern storage class is not for declaring a variable. Instead, it gives a reference of a global variable that is visible to all the program files. Okay, so the variable declared as extern are not allotted any memory. It is only declaration and intended to specify that the variable is declared elsewhere in the program. Okay, so extern type declaration is not for declaring a new type variable. The extern keyword indicate that, or extern keyword indicate the compiler, or is an indication for the compiler that that particular variable declaration is available as a global variable somewhere inside the program. So we need to find out the location of that particular variable declaration first. Okay, that means which is available somewhere inside the program as a global variable. So in order to understand the concept extern properly, we need to identify, or we need to understand the concept of global class. Okay, so consider this program, consider this one first. Okay, so consider here we have okay, consider here we have two functions, display1 and display2. And inside this main function, here we have one variable declaration n. This is an auto type variable now because its declaration is available here in this main function. Right? So its life exists inside this main function body. So here it display the value of n, and it's called display1 function and display2. Right, and here in display1, here it perform the increment operation of n and display the value of n. And here inside display 2 also, it perform an increment operation of n and display the value of n. What happened while executing this? It will returns an error case. Why? Because this n is an auto type variable. Auto means a local variable of this main function. We can't access this n value from outside of this main. But here it perform an increment operation of n here inside this display 1 function body and in display 2 function body also. This is not possible because this n is an auto or local type variable of our main function. Its scope exists inside this particular function body. So here inside this we can access this value directly like this. Okay, now we can execute. While executing, it display an error in display 1 and display 2. What is the error? N is undeclared. The used n is undeclared because the scope of n here it exists inside this main function body only. Okay, now we can make certain changes. I'm going to declare this variable here. That means which is declared outside of all the function body. Right? This n is declared outside of all the function body. Okay, and I am going to initialize this with a value 0. Right? I am going to initialize and declare this value outside of any of this function body. This is not present inside this main function and also not present inside this display 1 function, not present inside this display 2 function, which is available outside of all the functions available in this program. What happened now? Now we can execute this. It will display the result inside the main function. It display the value 0 first. Okay. Then inside the display 1, inside the main function it display value 0, and while calling this display 1 function it increment by 1 and display the value 1, and while calling display 2 again it incremented and display the corresponding result. N equal to 0 first, then while executing display 1 function it display n equal to 1, and while executing display 2 it display n equal to 2. Okay, so this is the case of global declaration of a variable. If it is declared outside of all these functions of this program, then we can access anywhere inside this program, inside any of these functions. These values are available anywhere. But if it is an auto type variable or local of any one of this function body, we can't access from other function directly. Okay, now we can consider this. I am going to change the position from this to here. What's the meaning? Now also this particular n variable declaration is outside of all of these three functions. Outside of all the three functions. Okay, but this declaration is present after the main function body and is present before this display 1 and display 2 function body. Okay, now we can check the program execution once more. Here it gives an error, that is n is undeclared. Inside which function? Inside main function. Right? So this is the case of global declaration. Here this declaration, global declaration of n variable is present after the main function body. So we can't access this particular variable, global variable n in this body. Okay, but it is before this display 1 and display 2 function body, so we can directly use this global variable value n here and here without any problem, right? But here it is not possible to access this value of this global variable n here in this main function because this main function body is available before this particular global variable declaration. So the best way or the proper way of global variable declaration is before all the function definition. Okay, now it gives the result without any issue. So this is the case of global variables. Global variables means a variable declaration outside of all the function definition. Okay. We don't want to include that declaration inside the body of any of this function. Then that variable become a global variable. Okay. Now we can consider the concept extern. This extern actually indicate or give a reference to a global variable that is visible to all the program files. If a variable is global, then it is visible to all the program files or all the functions available in a program. Okay, the variable declared as extern are not allotted any memory. This is not a normal declaration. The keyword extern actually not indicate any memory allocation. It is actually an indication for the compiler that that particular variable is declared already somewhere in the program. So this extern keyword actually is a command for the compiler to find out the location inside the program where that particular variable declaration is available. Okay, the default initial value of external integer type is 0 or null. Okay, so the default value of external type variable is integer 0. We can only initialize the external variable globally. That is, we can't initialize the external variable within any block or method. We can initialize only globally. That means outside of all the function body. We can't initialize such a global variable or extern type variable inside any of the function body. We can't initialize. Okay, we can initialize outside of this function bodies. So consider this particular program with int main function, in which here we have a global variable a. Okay, so while executing this particular statement, what the compiler identifies? The compiler identifies that this int a is associated with the keyword extern here. So from this it is clear that the particular integer variable a, that particular declaration is available as global declaration somewhere inside the program. So first we want to locate that particular location in which that particular memory allocation or the declaration statement is available. So this extern int a never indicates that this is a variable declaration. This particular statement actually a command for the compiler to identify the location inside the program where that particular actual global variable declaration is available. So the compiler want to identify this location. Okay, so consider this example, int a, and inside this extern int a equal to 0. This particular command actually indicate an error situation, because from our previous statement it is clear that we can't initialize an extern type variable inside any of the function body. We can initialize here int a equal to 0, but this is a wrong syntax. We can't initialize the extern type variable with a value inside any of the function body. We can't initialize. This is an error statement. Okay, we can initialize here because this is the actual declaration part of this global variable a, and this is a command to the processor or command to the compiler that we need to identify the location in which the particular variable declaration is available. Extern keyword is never indicate a variable declaration. It gives a command to the compiler that we need to identify the declaration location of this particular variable, integer type variable a, which is declared somewhere else in the program. We need to identify the location. That is the meaning of this keyword extern here. Okay, and one more, we can't initialize the value of this extern type variable inside any of the function body. So this is a wrong statement. Okay, so all these are about the 4 storage classes of C.